Today we're going to take a look at the double linked list challenge from Topcoder. Now, double linked list works pretty much the same way the array method works, or the array class or object works in Ruby. It sets up a list of items that can be traversed both forwards and reverse. And it does this, or it gives this ability, by setting a pointer to the next link in the list for each link, as well as a pointer to the previous link in each list. So this doubly linked list is created off the base node called a link. Link is initialized using the key and value. The key is the index of the link in the linked list, and the value is, of course, the value of that item. Again, the next pointer points to the next item in the list, and the previous pointer points to the previous. So when the doubly linked list is initialized, the head is set to a new link, because you can't have a list without a head. So it's set to a new link at key 0. Now notice that I'm not setting the value of this link to anything because we haven't actually given that link a value yet. That link will be given a value as we traverse the list. Again, the reason we do this is because we want to be able to insert a link anywhere in the list without having to give a value to an item in that link. In that list until we want the value to be set at a particular index. All linked lists have both a head and a tail. So the tail is just the last item in the list, the head is the first item in the list, or I should say it's a pointer to the first and last items in the list. When the linked list is initialized, the head and tail should be the exact same node. And then finally, I just went ahead and put in a length or initialized a length value for this list. That way I don't have to build a separate length method. And as links accumulate in the list, I just add one to that length so that I can draw the length value or the size value. Well, it will only be length in this particular item. The next method is the setter method. This works just like array. So if I want to create a value in an array, I would do something like array 0 equals 1. And I can do the same thing with this list using this particular setter method. This will also insert a value at any index in the list. And the previous values in this particular linked list do not have to be given just yet. It will hold a space in that list until we get to the particular index. And I'll show you how that works in a minute. But notice that when I do this, I have to traverse the list. So in order to traverse the list, I have to set the current link, it's a value called current, to the head of the list, and then I start moving over each item in the list by calling the next value in the current link. So basically I'm using this value to get to whatever key I want to add. So again, in array 0, I'm looking for index 0, but if I wanted to go to array 5, then it would traverse all the way until I get to the key value of 5, and then place the value 1 in that link. So at this point, if the value of tail is set to nil, then I need to move to the next node. So tail is going to be the current node if the next node is undefined. This is just going to move that tail value to always to be at the end of the doubly linked list as we're traversing. Again, the list is going to be built out until we get to the index that we need in the list. So that tail has to be moved every time we set a value that's beyond the head. Okay, and then again, we're leaving space for the links in the list that we're not setting values for. So again, if we're setting a value at index 5 and we don't have values from head to 5, we've got to create spaces for those, so memory locations for those values. And I do this by asking whether or not the current .next is nil. If it's nil, then I have to set a value, or I have to create a link in the list for that nil value so I can actually traverse to it. So I do that by creating a new link and setting its key value to whatever the current key is plus 1. Notice I'm not setting a value for the link itself, and I'm not setting a previous for that link yet. Sorry, I'm not setting a next for that link yet, because I'm not sure I'm going any further than that, but I do set the previous value as whatever the current node value is. If, however, the current node has a next that's not nil, it just moves to the next, or it traverses to that next value. And then finally, I set the current value to whatever the current .next value is. And so I'm traversing this link, just going through this iteration. And the reason I can't use the each method for this is because I have to create new links if a next value doesn't exist. All right. Then finally, I have to move the tail to the end of that. Again, we're moving the tail as we go, but when I get to that last node, remember I'm not going into this because it's an until loop, so I have to set that tail to whatever the current value is if it's the end of the list. And then current value is going to be equal to the value we pass in, and then of course I'm adding a new link into this, so my length is now plus 1. All right, the next method will just return the value at an index. And here I'm using the enumerable each with index rather than going through this entire process, because I've included the enumerable method, or enumerables, into this class. So I can do this, but I have to actually build an iterator into the class, and I do that by creating this each method. And the each method is just going to, again, start at the head, whatever the head is. So I set current equal to head, and basically until current is nil, so basically until I get to the end of the linked list, I'm going to yield the current value for the link that we're on, and then I'm going to move to that next value. All right, so with this enumerable built in, I can use the each with index, that's part of that enumerable mark, to actually iterate over the list and return whatever the link is at the value passed in, or the index passed in. So again, if I get, or if I want the value at array 5, I would type in array 5 in brackets, and it should return what we set it as, which was 1. All right. The next method just returns the head of the linked list. So whatever the head value is for the linked list will be returned with the first. So again, just like an array, dot first will return the first value in that array. This dot first would return the first value, or the value at the head of the list. An array can also use a dot last method. So this last method will return the value at the tail. So whatever that value is will be returned. And we already talked about the iterator, each, how it yields the current block or the current value for whatever link we're on at that point. Okay, so let's go ahead and see how this all works. So I've built in a test block, and this is just if we run the file. So if I run Ruby double linked list.rb, what it's going to do is going to create a new double linked list called list, and then it's going to use that setter method to set link our list 0, 1, and 2 to the values 1, 2, and 3 respectively. Then it's going to use the each method to iterate over that list and print the value of the list. Then I'm going to actually change the value at index 2 to 5. So the first time it's going to print 1, 2, 3, and then it's going to print 1, 2, 5. Right. So we see that it prints and works appropriately for that. If I wanted to actually print the first item, I could print list.first. And notice it prints the first item there. And I could also do the last item. And notice it prints the 1 and then the 5. All right, so we've seen it insert, we've seen it iterate over using each, we've seen it print the first and last items, and these are the methods that are being tested in the spec file. So let's go ahead and clean this up just a little bit. Just give you a simple test, and let's go ahead and run our spec. And remember, it's located in the spec folder, and it's going to be called double link list. Okay, spec.rb. We get 5 examples, 0 failures, and then we're done. All right, if there are any questions, please post them in the forum, and I will answer them as soon as I possibly can. Thank you.